welcome back to the OATI Energy Conference 2024 in Las Vegas. I'm John Engel, Editor-in-Chief of Distributech and PowerGrid International. I'm joined today by Erik Amundson, the Chief Technology Officer at OATI. And Erik, before we get into some of the nitty-gritty, but help frame OATI's role in the microgrid space. Where do you guys slide in?
Well, OATI has a very popular and well-adopted DERMS platform, the Web Smart Energy DERMS system that helps utilities dispatch distributed energy resources and manage them, monitor them. And we also have a microgrid control package called GridMind, which sits in the field, in a control enclosure and actually directly monitors and controls the assets in the field to facilitate the functions of a microgrid.
I want to talk about that a little bit too, and like what's actually happening at the asset, because I think at a high level, when we talk about microgrids, we obviously go to the resiliency benefits and reliability. But when not in one of those situations, they're operating and participating in markets and serving the grid in a number of different ways, just like any other asset would. And I know that the software underlying that is what allows it to be dynamic.
Yes, and it really depends on who owns the assets and what they want to achieve with them, right? So a lot of our systems are utility-owned microgrids, distribution connected. And yes, they do fill a role for resiliency and reliability for the local feeder or neighborhood or whatever they're connected to, commercial buildings sometimes. But the utility also uses them via the DERMS package to perform a variety of functions on the grid, everything from power quality to voltage support, frequency support. They also use them for peak avoidance and just energy savings. A lot of them are solar battery combinations, so the battery charges automatically from the solar, and then they discharge the battery to avoid peaks from their generation providers.
I was chatting with someone over at North Carolina Electric Cooperatives too, which I know uses the OATI's DERMS, but also the microgrid software, and hearing about how they worked together with you to evolve that platform both on both applications. How has that software suite improved over the years and been able to provide more functionality to the customers you serve? And maybe you can even throw in an example of kind of the emerging use cases that have developed over time that may not have been there during the origin story.
Sure. So the genesis of the GridMind software package was OATI's own building. It's a commercial.
I've seen it, by the way.
Yeah, you've been on the tour.
Yes.
Yeah. We have a combined heat and power system there, and we run what's called the optimization module to perform either carbon emissions-based reduction or operational cost reduction. And so the software was originally kind of devised for that, but we always had in mind the purpose of kind of productizing it, selling it to our customers and deploying it to better enable them to use microgrids and DERs. So that was kind of the genesis of the product. Now, how it has transformed is we have a lot tighter integration now with DERMS, especially OATI's DERMS, but we can also interface with any other control product out there, really, with the GridMind product. And the product has also had features added to it. For instance, volt-var, functionality, frequency watt, all those dynamic grid interactive control mechanisms. And what the software brings over just using an integrated DER controller to do that is it can make the whole site perform as a nice uniform asset on the grid, right? So if you've got a microgrid with, several batteries, generators, PV inverters, a whole bunch of things. We have one actually with 40 PV inverters, which is not uncommon. You don't have to worry about the health and status and capability of all those little itty-bitty DERs. If they're in the envelope of the microgrid, GridMind will just make them behave nice at the interchange and deliver the VARs you want or the wattage you need to help hold up frequency or whatever the control mechanism may be. So that has been a use case we have continued to improve and make the functionality of the microgrid controller as a site controller provide advantages to the utility, not just when the power goes out, turn my lights back on.
Yeah. I always think of microgrids like snowflakes, like they're all very unique. And with that comes deployment challenges and a different approach than you would have for other assets. What do you think about in regard to the most critical elements of microgrid deployment? Because it is different than some of the other things we work on.
Yeah, I would say that is in large part true. Every microgrid is very unique. However, there is a bunch of commonalities that you can pull from, especially if you've experienced deploying more than a few of them. I think the challenges to successful microgrid deployment can be summed up, in my experience, into a couple of categories. One is controls integration to achieve what the customer wants to do. And the other one is making sure that the assets you purchase or deploy are actually capable of what you want to do. A lot of times in that category, you end up with folks that purchase assets and don't realize the specific things they should be looking for in, like, for instance, inverter features. How much inrush can the inverter handle? How much ramp can it handle in a fast period of time? So there's all those. Does it support droop control to parallel with another generator? With all those complicated things that sometimes aren't thought of until after the fact and present challenges.
So how do you work with the OEM community, or tailor your software to be adaptable to kind of whatever they bring to market, to make sure that when you go to integrate with primarily the utility, that whatever they've picked off that catalog it's going to work ultimately?
So in GridMind, we have kind of a general purpose SCADA system that is very configurable, right? So all of our abilities to issue controls and collect telemetry and data from the DERs is very configurable. It's supports standardized protocols that almost all the DERs support. In addition to that, we have a custom sequencing engine that allows us to perform a variety of sequences. As the product has matured, we now have repeatable code blocks of sequences we can deploy. And a lot of times those combinations of code blocks will allow us to achieve things that otherwise you wouldn't be able to, especially using a combination of resources. So another feature we have is the ability. We built enhanced functionality that isn't, it's integrated with the function instead of individual manufacturers or models of equipment. So for instance, if you're trying to perform power factor correction, we have a method to do that with any device that will support a reactive power command, and almost all of them will. But they all have different features and limits and functionalities, but we've designed all those features to be configurable to fit in the limits of what you have to produce the desire you want at the interchange, basically.
What's great about this conference is not only the education, but it's a customer event for you guys. So it turns into this giant focus group, and just bopping around to the different discussions, you hear a lot of questions, and it's very candid and open in a way that even what we do with Distributech, sometimes you don't always get there. They know exactly who they're talking to, and they can get to the point because you guys are partners. What are some of the biggest questions that you're getting today then, as we know that energy transition is rapid and very dynamic? What are customers asking you about the microgrid space particularly? And are you seeing a heightened interest in this space just due to the volume of events that are testing the grid?
I am seeing a heightened interest, definitely. As years have gone on and on, we've had much more interest in microgrids. I think one of the things that is driving that is the distribution utilities especially are starting to see that instead of spending $7 million on a new feeder to feed redundant power to a neighborhood or something, they can spend half that maybe on a microgrid. So there's this stigma out there that microgrids are expensive and won't pay off. And well, how are you justifying it if it's an alternative to doing something like that? And then also the asset can perform, power quality and peak avoidance for you. Then suddenly the financial picture, they really start to pencil out, and it starts to make sense. One of the things that I was amazed at this conference in particular is how we've developed a tool called Digital Twin, or D2T, which allows you to simulate a power system, and we're using it as an underlying testing tool to test out the sequences in the GridMind system, right? It simulates voltage frequency very, very fast. And it's a software-based simulator, but we have been talking to customers at this conference about that being an enhancement to our ability to deliver GridMind and microgrids. And we have a lot of interesting questions in the simulator. So I think that's just another step towards making customers who are thinking about microgrids more comfortable with deploying them, because now they think, well, I can simulate the thing and see in a simulator that it's actually going to function and do what I want it to do, before they, cut the check and buy all the big resources that it can cost all the money. So
you opened the can of worms of non-wires alternatives very, very quickly. So I would love to talk about that a little bit, because we do know there's value there and there's a lot of potential. In the example you used in, do you do a $7 million line or feeder upgrade, or do you build a microgrid at half the cost? Much of the discussion with non-wires alternatives has seemed, to me at least, to remain in the conference session environment and not necessarily gotten to deployment. Some states are more advanced than others and are beginning, program rollout, whether, California, or I know Avangrid's got a lot of stuff in motion in Connecticut. But thinking about how we get to a point where that is as much of a solution and opportunity as building that line, and utilities are taking full consideration of that. How far away do you think we are? And maybe that's already in motion and I'm, missing the boat.
Yeah, it really depends on the parties at play and the geography of what you're talking about, right? So I think in some areas, it's already there. Customers are already doing that. I've already had conversations with a few of them at our conference here where they are already, using microgrids as a alternative to building distribution or even sometimes transmission. But that's not happening everywhere yet. And I think the more, part of it is just the more prevalent and more examples there are out there of functioning microgrids that provide these advantages, the more use cases people see, the more their eyes are opened up to the possibilities of doing this instead of traditional distribution or transmission construction. But also, I think that's where a lot of this interest in the simulator is coming from. They want to be able to, for lack of a better word, play with it in a simulation environment and see that they have some assurance that it's going to do what they want it to do and it's going to help out their part of the grid, and see how it reacts to adverse conditions. You don't install microgrids for the perfect sunny day operation. You install them for when, you've got trees falling on lines and transmission voltage problems and generators that aren't working. And, that's why you have them there. So providing the simulator and more examples of them functioning in the wild is probably going to help a lot.
Erik Amundson, thanks for joining me.
Thank you very much.